back to just one slide. Okay, so welcome to the Python Programming for Beginners short course. Okay, so in the beginning, we didn't have Python, right? So, and also in the beginning, we should, to start with, we should take like a look at the foundation of programming languages. So this is a table showing how computer technology has moved over the years. Okay, so the top row shows the hardware. Okay, so computer hardware moved from first generation to now fifth generation. So in hardware, it's quite easy to differentiate the technology. Okay, first generation is vacuum tubes, and then is transistors, IC, VLSI, and today we have what's called many core, where you have maybe 50, 100 or more cores in one IC, and also we have quantum technology, quantum computing today. So that is the state of the art for computers today. And then memory size was very small in the old days, and now computers are measured in terabytes of memory. And then speed-wise, previously we measure by the cycle time. So how fast is your computer? We measure by how small your how many milliseconds it needs to run one cycle, and then it goes down to microsecond. And then by the third generation, we look at the performance in terms of millions of instructions per second. And then by the fourth generation, people talk about floating point operation per second, so flops. Still used today for many operations, for many situations. But for 5G, we probably will see tops or tera operations per second. Instead of floating point, or maybe megaflop or teraflop, now we just go to teraops. So because I think presumably it's easier to pronounce than flops. They just call it tops now. Okay, so in okay, jump down to the last row, we have some representative computers, but going back to the second last row, we have see that the programming languages also moved from generation to generation, but it's not so clear. Okay, so first generation computer is easy, but first generation language also easy. So because it's machine language, and then second generation programming language is assembly language, and then third generation is high level language. But fourth generation and fifth generation computer languages are not that clear. So if you see people claiming fourth generation language or fifth generation language, take them with a grain of salt, meaning that don't believe what they are saying. Check first. Okay, next we go to the evolution of programming languages. So as we have seen computer hardware evolve, programming languages also from hex code or machine language. In terms of generation, this corresponds to first generation language, and then people come up with assembly language, which corresponds to second generation language, and then we have C, Fortran, C++, Java, and Python. So all these are in the same group. They are all third generation languages. Okay. But we have some different levels of what I say intuition or high level. These languages, these 4 or 5 languages, they have different level of intellectual capability in using them. So C is quite low level. It's almost like assembly. Fortran is a bit higher than C, even though Fortran was originally introduced before C, or maybe around that time also. But I think Fortran is quite old. But Fortran is actually still being used in supercomputers today because it's considered, it is free. You don't have to pay to use Fortran. And then we have C++ and Java, where these are the first attempts in wide-scale object-oriented language. Okay. There were all the object-oriented languages, but C++ and Java made the term OOP or object-oriented programming popular. Okay. And then lastly, we have Python and its relatives. Okay. Python is also it is object-oriented. It has some equals. It has some equals, such as PHP, Ruby, and Perl. So they are all today called scripting languages. So if you look at the types, if you look at all the programming languages, you can classify them into either imperative, where you tell the computer what to do or how to do. Okay? Imperative means you tell the computer how to do something, or we have declarative, where we tell the computer what to do. These two are quite different in terms of usage. Okay, so imperative falls into two groups: procedural, like the one that we used to use. Okay, procedural examples are C and Fortran, and then we have object-oriented, such as C++ and Java, as mentioned just now. And then we have on the other leg, declarative languages, where you don't tell the computer how to solve a problem, but you tell it what you want to solve. Okay, so let the computer find its own way to solve the problem. So these languages are used a lot in artificial intelligence, and there are two groups there: logic and functional. Okay, actually logic I don't know much. What makes it a logic programming languages? But functional languages, in functional languages, you write a program in terms of function. So like fx equals sin x, okay, something like that. So the whole program will look like that. Okay, so because procedure-oriented or procedural languages and object-oriented will be the main core of Python, so I will talk a bit just on the differences between the two. Okay, so procedural-oriented programming means that when you write the program, you have to think about the functions or the procedures that you are going to use in the program. Okay, so if you look at the diagram on the right there, we have main program, and then we have functions or procedures. Okay. So that's why it's called procedural language, because you write the program in terms of procedures. So a procedure called another procedure, and so on and so on. So when you start sitting down to create a program, you think about the main program and all the procedures that you have in the program. And then the other feature of procedural programming is the data is global. That means all the procedures can access the same data. That means if function A modify the data, global data 1, if function A modifies global data 1, function B and function C will also feel the impact, because it's the same data that everybody is using. So to avoid that, to avoid, for example, doing mistakes or modifying your data accidentally, we also have local data. But in the procedural programming environment, normally the local data is not that much. Most of the data will be in global data. Okay, so that is the characteristic of procedural programming, and we still use it. Okay, so if you use C programming, this is how we design stuff. But when your program gets bigger, this type of programming style is not easy to handle. Okay? So you tend to make mistakes because you make changes to the global data. So that's why people introduce what's called the object-oriented programming. In object-oriented programming, we think of the program not in terms of procedures, but in terms of objects. So each object has its own operations or its own capabilities, and it will have data that it controls. Okay, and in OOP, or object-oriented programming, we call the local data attributes. So these attributes are mostly private, or they are local or owned by the object, and the other objects or the other parts of the program cannot modify the data accidentally. So when you have a big program, this feature will help you a lot to make sure your program still works. Okay? Because if you accidentally modify data, the whole program doesn't work. So by doing object-oriented programming, you make sure there is very, very minimal changes to data that is owned by others. So that being said, that means the OOP, how it works or how it's better than procedural is because it's modular. Everything comes in, everything is done in terms of modules or objects, and then it's easy to develop for a big team, and then it's ease of maintenance. Okay, so here I put the bracket big there. Okay, big object-oriented software is easy to understand, therefore easy to test, debug, and maintain. So your program must reach a certain level before you can appreciate object-oriented software. So if your program is only like 10 lines or 20 lines, like your uh, weekly assignment, you're not doing that anymore because you all graduated, right? Like if it's a small program, maybe you don't need object-oriented programming. But let's say you're talking about software that controls an airplane, okay? Millions and millions of lines of code. The program itself is very, very big. So at that time, you will appreciate object-oriented programming. And then number 4 there, once you have the objects, some of the objects can be reused because you can see that many when you're doing programming in object-oriented programming, when you're doing object-oriented programming, many of the objects will do something that other people can make use of. So you have code reuse. When you have this, you will reduce the cost of software development on the long run. Not for the first version, but maybe for later versions. And also, OOP will force the developer to think at high level, because to do OOP, you need to be able to think in object-oriented terms. Everything has to be converted to objects. So when you do that, the level of effort that you put will be higher, and you have to be basically more intelligent to develop object-oriented programs. So the software quality is higher. Okay, so I think that's it. Okay, one more, but I think I can one more. Right. So then there are the programming languages can also be classified into compilers or interpreters. This is a big table here. But basically, I think you go to the third line. Okay, what's needed to run? That's the main thing. Okay, if it's a compiler, you compile the program, you produce the executable code, and when you want to run it, you just need the executable code. So in Microsoft Windows, you just need the .exe. You don't see the original C program, you don't see the compiler, and all that. You don't see that. But for interpreted language, you need the source code. So if you have a Python program, you still need what's called the interpreter. So you need both to run. So that's the main difference. But of course, there's other difference, like for compiler, you need to compile it. So compilation may take a long time, but once you compile it, it's very fast. So for the interpreter, it is usually slower, but for many applications, slow is not the slowness can be tolerated, and actually for some applications they run about the same speed. So that's why interpreted languages are getting popular now. Okay. All right. So I think we can go to the next step to set up Python and find out what is the origin of Python. Okay. So who created Python? It's created by Guido van Rossum. Maybe I got the pronunciation right, maybe not, because this guy is a Dutch. He began working on Python in late 1990s, and then he released it in 1991. Okay, he is now working for Microsoft. Okay, so there's four features of Python there, four important things when people ask you what makes Python different than other languages. Once it is an interpreted high-level language. Okay, so by saying interpreted, that means you have to know what's the difference between interpreted language and compiled language. And then it is a general purpose programming language. Is can be used for many applications. And then the design philosophy emphasizes code readability. Okay, some people don't like Python because they have to do things, they cannot do things any way they want, because in Python you have to do things the Python way. But for a lot of other people, they prefer code readability first. So code readability means you can look at other people's program and you can pick up immediately what was being written. So this is very important in software engineering, where you have to look at old programs and make modifications. And also here, Python supports multiple programming paradigms, including procedural, object-oriented, and functional. Okay, so we've seen procedural, object-oriented, and functional. Suddenly we have something here that supports all that. And it is consistently one of the most popular programming languages. Okay, so why is it called Python? Or is it Python? I don't know. Okay, if you talk to an American, they will say Python. Okay, but to a Malaysian, we say Python. But if you are pronouncing it making Python as part of a uh, making it you're making a word out of Python, okay, such as Pythonic. Okay, your method of working is not Pythonic, so it cannot be Pythonic. So that means you have to still, the correct pronunciation probably is Python. Okay? So the name comes from BBC series in the 1970s called the Monty Python's Flying Circus. It's not because of the snake. Okay, 10 reasons to learn Python. Number one, ease of use. Number two, extensive support libraries. So this is important because you can add anything to it. Okay? So from the basic Python, you can add libraries and to expand it to have more capabilities. And then machine learning, why is it like that? Why is it just saying machine learning? It's because today Python is like synonymous with machine learning. If you want to do machine learning, you learn Python first. And then it is extensible. I think extensible and extensive support libraries, they belong together. And then we have embeddable. Embeddable means there's actually a version of Python that can run on embedded systems called MicroPython. And if your computer is not small enough, you may have Raspberry Pi. Okay, so Raspberry Pi is like so also an embedded system, but it has Linux inside there, and because of Linux, you need to use Python to write programs for it. Okay, Python is also quite fast. Of course, you cannot beat C or machine language, but some of the libraries are written in C. So if you call those libraries, you will not see any difference. And Python is used a lot in web development, like my software engineering class today, they are writing program in Python with what's called the Django web framework. So you can do that, and also you can they are doing that on the server side. So the web development actually comes together with the server side scripting. Okay, so previously people like PHP for this type of work, development, web development, and server side scripting. A lot of people still use PHP. As PHP code gets older, people hate to look at them because the way PHP is written is just like C. You can write in one line, you can write in 5 lines for a 5 statement code. So both types of writing code will work, but really not easy to maintain or to make corrections. And then lastly, I don't actually understand what that means. I copied this from somewhere. A less limited programming approach. Okay, I don't think to everything. So let's leave it at that. Here is the ranking of popularity of Python. Number one for quite some time. Okay, so you can click this link if you have your PDF, tiobe.com. Okay, again, don't ask me how to pronounce this, but this index is updated monthly, and you can also have like 10-year series data. For example, what is the ranking of Python in the previous 10 years, or what is the number for Java and so on. So Python was originally, of course, they started low, and then it reached number 1 or number 2. At the worst, it is number 3. for the last 10 years. Okay, if you look at the third column, I have application column. Application here is for differentiating the applications of where a certain language is used. The globe here means is for web development. So Python is used for web development as well as Java, C Sharp, JavaScript, SQL, and so on. Okay, and then second column is mobile. So that looks like iPhone or iPad. So Python is not used. Okay, it's the only place where Python is not used. I don't think you can write Python code for Android easily. It's possible, but not easy. So for writing code for mobile, Python is not there lah. Okay, it's the only one that's missing. It's the gap there. And then the third column is desktop computing. Okay, desktop computing here, of course, because all the programming languages must be programmed. All programs must be programmed using a desktop. So of course, almost all runs on the desktop, except PHP. So you cannot run PHP code on your desktop. And then lastly, we have the chip here. This is for embedded. Okay, so Python can run embedded. C, of course, and then Java, C Sharp, C++, and then of course assembly language. So if you want to use your microprocessor, of course you have to use assembly language. All right, so I think that is the summary of it. If you look at this, if you have a chance, you go to this list, you can still see MATLAB there in the top 20, and also Python's neighbors, which are Python, PHP, R. Okay, R is some quite close, but this R is specialized to statistics. And then Perl and Ruby, okay, they are also in the top 20. Okay, so if you are using a computer, which way are you going to use your Python? If you have Mac or Linux or Raspberry Pi, nothing to do. Okay, you can access it using the terminal. And if you have Windows, it's not built in. You have to get the installer from Python.org, or you can get this IDE called Tony from Tony.org for an all-in-one solution. Okay, if you have Tony, just install this program and you can run many things. If you don't want to install anything, just go to this link here, replit.com, and select Python, and you can run your Python on the website. Okay, so you can do that right now actually. Yeah, so I'm not going to do these two parts. The two things here, the installing for Python or getting Tony. Okay, I'm not installing Tony on my computer because I don't need to. I already have Python on my Linux. Okay, so the quickest way to write Python code is using the interpreter. And basically, if you have used MATLAB, you know this is like MATLAB. So you type your Python instruction and you get your answer the moment you hit the enter key. And the interpreter is also called REPL, which means read, evaluate, print, loop. And REPL prompt is these three greater than signs. Right? So let's try that with, let's try this example here using my Ubuntu, which is in my lab. Okay, so I will be switching back and forth, but maybe not so often because I think maybe quite distracting. But right now I want to show how it's done using Linux. Okay. Okay, so here is my Ubuntu. Can you see this? Can everyone see my Ubuntu screen?
Yes, we can.
Okay. So let's say you are in Ubuntu, right? So you are in Ubuntu. So go to, I think go to activities, and type T. Normally I do this. Okay, type T, and then you see terminal here. Okay. Okay, so I already have something running on my computer now. Okay, actually, this is the Linux command prompt. Okay, so I hope it's not too small. Not sure how to make it big. Can I make it bigger? No. This is it's limited. Okay, so anyway, if you have the command prompt, you say clear, get a clean screen, and just type in Python. Okay, so I have Python 3.7.11. Okay, so there you have it. Okay, you can start now, and then you can use a Python like calculator, like an interactive calculator. So for example, 4 plus 1, you just enter like that and you get 5. I think it's the same thing in MATLAB. Okay, and then if you have a longer program, it's better to write a program in .py extension. So let's try this. Okay. Okay, of course you can do this. You can say print hello here. Okay, print hello world. This is the first program that people write when they learn a new programming language. Hello world. Okay, and it would be hello world. But let's say I want to write it as a script, okay, or as a program that can be saved later. Okay, because this one they cannot be saved. So I need to quit. So I just hit Control Z. Okay, Control Z will stop, and you're back to the command prompt. Okay, now in Linux or in Raspberry Pi, there is a built-in simple text editor. Okay, so what you can do is just type nano. Okay, the nano is the name of the text editor, and then give the name hello.py. And then here I say print hello world. Okay, then I write Control O. Okay, go if you look down here, Control O means write out or save it. Okay, save to hello.py. Then Control X to exit. And then I can run the program, say just by typing Python hello.py. Okay, so that's the program running. Okay, so we need the Python interpreter and the program itself. So as I mentioned, this is an interpreter. So you need the Python interpreter and the program.py, the .py program. Okay, so if you look at this is my directory, a lot of junk there. You can look at the program. You can look inside the program by typing cat. Okay, if you don't want to edit, just want to see what's inside, just say cat, and that's the program. And I can make this program run like an executable, okay, like in a PC you have exe. So here you can also do that, but I cannot do right away. Okay, for example, here I cannot type in hello.py. It will not allow that. So what I can do is I must modify with what's called a shebang. Okay, so go to the next slide. Another way, the third way to make a Python program is to add what's called the shebang line, which is actually the address of the Python interpreter. Okay, so I can type Python like this, right? Okay, I get the interpreter, but I can find out where is the location of the Python interpreter. So I can type in which Python. Okay, I don't like this. This is Anaconda. Okay, anyway, I'm using Anaconda because I'm doing AI, so I have to deactivate this. So see this, the base here. This means I'm in the what's called the virtual environment. In Python, you can use virtual environments so that you can have many versions of your machine language program for some reason lah. Okay, that one is out of my scope for today. Anyway, I can still run the code just now. I can still look at the program, even though I'm out of the virtual environment. But if I look at, if I want to find out what is the path to the interpreter, it's now user bin slash user slash bin slash Python. Okay. So what I need to do now to the shebang line, I need to copy this. So I go back to nano hello.py. Okay. Try to remember is slash user slash bin slash Python. And then I put this command line. Okay, go check here. Okay. Oh, I need to put hash exclamation mark. Hash exclamation mark. So this is the bank. Okay. The bank character, the hash we know, right? There's a hash character, and then there's a bank, but somehow combined they become shebang. Okay, now if I do that, I still cannot run, but let's try anyway. Okay, still permission denied because it's not supposed to be run. So in Linux, I can do this. I can change it to what's called the executable type. So plus X will give execution permission to the script, and then give the name. And now if I key in, it should run. Okay, so it is considered now an executable program. But when Linux looks into the program, it will look at the first line. So it will find out where is the location of the interpreter, and then it will execute. So this one I can easily do in Linux or Raspberry Pi or Mac Apple, but I don't think you can do this in Windows. Okay, so next in the agenda is writing some simple programs. Okay, so as I've shown, you can use Python as an interactive calculator, and the result can be integer or floating point, whichever is simpler. So instead of showing you this, I will immediately go to the screen here and show maybe quite small. But anyway, Python again. Now it's version 3.8. Yeah, I have two different versions in Python because I'm running in two different environments. Maybe I need to find out how to make this bigger, but if it's okay, I just keep it. Is it okay? Is it too small, guys?
For me, it's like it's too small.
Okay, I need to find out how to make it bigger. Not the screen, not the bigger
And
screen.
not the screen, the font. I mean, maybe cannot.
There must
Maybe
be.
my eyes problem.
No. It's not your. It's not you. It's not the program. It's not that. It's a thing. I think I have to find out how. How
How about the participant? Can you see?
I think I changed it from the options, right? On the upper right hand side, there's a font for the terminal.
Where? Here, this one? No, this one is to maximize.
No, the double dot, the hamburger symbol.
Oh, this one?
No. Inside your Munian terminal, there's a hamburger, right? Next to the search icon.
Hamburger?
Yeah.
This one?
Yeah. Then probably there's advanced or preferences.
Yeah. Let's try that.
And then maybe there
Thank
is
you.
global or font, maybe. General.
Nothing to do with font size.
So if not, you go back to the hamburger one, and then under the hamburger, maybe there is advanced.
Yeah, I reduced the character size. Number. No. Doesn't work. This one. Bigger? Yeah, it's bigger.
It's bigger than before. Yes, correct.
Yeah. How come I didn't see this?
Yes, you can just click that. Yeah.
Yeah, just waiting for Osman to mention it.
Right. It's big for me. I can see it without my spectacles now.
Yeah.
Thank you.
I think I can make it bigger. I think I want to make it one step bigger. But TeamViewer is okay. All right. Okay, so anyway, okay, so we can use the regular operations here. It's quite slow lah. I think I think my CPU is choking because of the video and also the team viewer. Okay, anyway, okay, this one is important. Okay, if you do the 1 divided by 3, you get 0. Wait, how come I don't get the same thing? Oh no, I'm supposed to get 0, but now I have 0.3. Okay, so this one I don't know why. It's supposed to be 0. Okay. Not sure why. Okay, I did it on my Apple just now. I got 0. And if I really want to make it, if I want to really catch all the fraction, I have to put dot normally. Okay. So what I was trying to say was, it will use the easiest or the lowest data type, which is integer, as much as possible until it cannot run away. So if 1 divided by 3 can be done in integer, it will do everything in integer. So if you do this math in integer, it will get 0. But somehow I'm not getting it. Wow. Okay, anyway, learn something new every day. So I have to find out why it's not giving me 0 now. Because some of the examples afterward will fail also. Okay, anyway, you can do exponentiation. Like for example, 7 raised to the power 2, just do that. And then you can also you can also do square root, raise something to the power of 0.5. So I think that one we're not sure whether it's correct, right? We know what is the power square root of 2, so it's 1.414. Okay, so we do get that. All right. Okay, math follows the PEMDAS rule. Okay, parentheses, exponentiation, multiplication, division, arithmetic, add, subtract, Okay, so PEMDAS or BODMAS, depending on whether you are British oriented or American oriented. So if you want to override the PEMDAS rule, or if you want to override something, you have to put a bracket. So if you do like 2 times 3 plus 4, it will do the multiplication first. But if you want to add first, so you have to put bracket around the addition, so that it will not do the multiplication first. And then if I have a series of steps like that, okay, see that 8 divided by 4 times 4 divided by 2. Okay, so it will do it from left to right. So 8 divided by 4 will get us 2 times 4 becomes 8, and then divided by 2 again, it becomes 4 lah. So, and I'm getting the answer 4.0. So it's already converted to floating point. When I did it last time, just now in Apple, I got just 4. Anyway, you can recall all the previous entries by using the up arrow key if you're using this wrapper or interpreter. And then if you want to override something, you can put the bracket. So let's override the last instruction. So this one should give us the same result, but let's say we put the bracket in the middle. So now it will become 8 divided by 16 times, and then divided again by 2. So I get 0.25. Right. Okay, yeah, the last one. Okay, the last one I get on my computer I get 0, but on this Ubuntu computer I get 0.25. Oh, scary. Getting different results. Okay, anyway, let's move on. Variables are easy to use and reuse. Okay, so in Python, you can use variables normally. Okay, which means that the first character must be alphanumeric, and then you can the subsequent character can be alphanumeric or number, or maybe 1 or 2 of the special characters. Okay. So let's just use all alphabetic characters. So if you put there 1 equal to 1, and then you multiply that by 2, you will get 2 as the result. And then if I use 1 equal to hello, what happens is that 1 now stores a string instead of a number. Let's try that. 1 equal to number 1. If I just type 1, I will get back the result. I will recall the value of 1, and I can multiply that. Okay, and then immediately I get the result for the calculation. And if I say 1 equal to hello, and I just type in 1, I will get hello back. But I can also do it the long way. If I say print 1, I will just get the hello without the quotation marks. So print will be useful in the program, because in the program you need to give the print command, but when you are using this interpreter, just type in the variable name. Anyway, you can try this. 1 times 2, you can do that. Magic, right? hello now becomes hello. All right, so wait, what about data types? Okay, in C programming, you have to worry about integer, floating point character, etc. Okay, Python's answer, next slide is called the duck typing. Okay, we don't have typing, we have duck typing. So duck typing here means if it looks like a duck, seems like a duck, quacks like a duck, then it's probably a duck. Okay, so what that means is that if it looks like a string, okay, if it looks like a string, streams like a string, and quacks like a string, then it is a string. So that's where the term duck typing comes in. Okay, so the opposite of duck typing when you're programming can be like strong typing or weak typing. Okay, so languages like C is weak typing because they can switch the type from integer to floating point. Okay, let's say I have an integer, I want to save it into floating point. It will get converted on the fly. Okay, you don't realize that it's converted from integer to floating point because it happened because your variable that you want to use as a storage is a floating point. It will be converted just like that. So that is weak typing because the type is weak, can be converted at any time. But languages like Java and Pascal, they are strong typing. You cannot just simply do that. You have to force the type change before you can store it. So and the integer cannot be stored in a floating point variable without forcing it to become floating point first. But here it's even weaker than duck. The duck is weaker than weak. Okay, so it can even change on the fly just like that, and you don't have to declare. All right, now instead of just floating point and integer, we can also have Boolean variables. So you can store true or false, and you can also you can also use the value in a calculation. Okay? So for example, 2 less than 3, of course, is true, right? So I can save this value. Okay, I can save this value into, for example, a flag. Flag equal 2 less than 3. So now I can type in flag. So flag is true. And then what is the inverse of that? I can say not flag. Not flag is false. Okay, the inverse of true is false. And also I can combine relations. Okay, so 2 less than 3, of course, this is true, but 3 less than 4 is also true. So the whole thing is true. And I can also save this value, of course. Okay, this one cannot be done in other languages, as far as I know of. And then let's say I do something crazy like 2 less than 3, which is true, and then I combine this with greater than 1. Okay, also true, of course, right? 2 is less than 3, and 3 is greater than 1. Okay, but how about this? 2 less than 3, less than 1. Then it becomes false because the whole operation is not correct. And only part of it is true, but some of it is false, so the whole thing is false. All right, and then in Python, you can do multiple assignments. Okay, so instead of A equal to 1, B equal to 2, you can do both at the same time. Okay, so A equal to 1, Of course, you can do this. Okay, and then you can type A, you can check out B, A and B. Okay, you can do that. Also, you can do A comma B. It will output both at the same time. But I can also assign A equal to, okay, I'll change to something else. Okay, I want to change A to 5, okay, and then B to 6. And then if I type, check out the value A is now 5, B is equal to 6. I can do that. And because I can do this simultaneously, I can also swap values very easily. So I can do A equal to B equal B, A comma B equal to B comma A. And by doing this, both will be swapped simultaneously. So if I type, check out A is now 6, B is now 5. Okay, so that's some of the things that you can do in Python. Okay, so this one, I think this slide is useless now. We've shown just now. It is quite useless. So in other languages, okay, like in C or, yeah, especially in C, the operations will be in integer as much as possible, and you will only convert to floating point only when necessary. But it seems like this version of Python use floating point already for everything. Okay, maybe I think my version was 3.7 and this is version 3.8, I think. Quite the difference. Okay, quite the difference. 3.8 here. Okay, so anyway, let's say you want to do mathematics with pi, right? So you can do 22/7, but of course it doesn't give 3 anymore. Now it gives 3.14. But if you are somebody who likes to make it quite accurate, you use 355/113, which will give you up to 7%, seven digit accuracy, which is the maximum accuracy of a single precision number in the computer lah. But of course, the default nowadays is double precision. So just saying lah. Okay, all right. So if you really want accuracy, you do what's called the import math, and you use the math that is already inside that. So you can type this import math, and then I just type in math.py. Okay, it's already part of the language, sort of. Okay, not really part of the language. It's part of the standard package. So the math is a standard package. So if you want a pi, you use math.py. Okay, and then we've seen some strings there, but now I'm just saying that strings can be enclosed in single quotes or double quotes, and there's no difference between the two. And you can do addition. Okay, you can add strings. You can also multiply string. I've seen that before, and you can also have a multiple lines in a variable. Okay, so let's try this. Okay, x equal to hello, single quotes, and then y is world, for example, in double quotes. Okay, and then I can do x plus y, or I can do x plus space plus y, okay, something like that. Okay, and if I print, I will remove the quotes. Okay, and then and then we have multiple line strings. So for this one, you need to use the triple quotes. So x equal to 1, 2, 3. Okay, this is a multi-line string, for example. So now close it with the triple quote again, and then when we type x, we will see this. This is a multiple line string, but the the end of line character is \n, just like in C programming. And if you want it nicer, you use print x lah. So then we'll remove the quotes and also process the \n to become a actual new line character. Okay, I think that's it for the moment. Okay, we'll take a short break. Then I need some drink of water or something. Okay, any questions you can post in the chat and then I will try to answer. Okay, short break.
So participants, you can fill up the attendance for the e-certificate. Okay, I have posted the link in the chat box. You can fill up the attendance. If you have any question, you can post in the chat box too. I'll try to read the speaker if you have any questions.
Okay, next, I'm back. Right now, I'm trying to use the web-based interpreter. Okay, let's see. Can do that. Also, I want to shut down one of the WebEx. things. It's making my computer slow. Not sure how. Okay, stop sharing this one. Okay, everyone, can we continue? Right. Okay, so the next topic is on flow control, right? Yeah, so when we compare things, okay, numbers or variables, we will get booleans, and I think I've shown I've shown it just now. We can combine things. Okay, we can combine the comparisons, and so we can use the keywords and or and not to modify the comparisons. And also the comparisons can be stored in a variable. So yeah, we've seen that also, right? So for example, 2, okay, let's say as a equal to 2 less than 3. Now a will have value true, and we can print that out. Okay, let's try to make this a little bit bigger. Okay, here I'm using the web-based interpreter, so you don't have to install anything. Just go to this link and can type right away. Okay, so you can also compare strings. So based on the alphabetical order, you will give a value of true or false. Okay, so if I say Python less than Java, should get some result, either true or false. Okay, should be false because J comes before P. So Java comes before Python in the dictionary, so you get false. Okay, and then from the comparisons, we can make conditional execution. So of course, the basic command for any language is if, but for Python could be different than what you used to, right? So you can write in one line. So in my example here, I have x equal to 42. If x is if the remainder of division, the remainder of dividing x by 2 is 0, print even. So if you print in one line, it works, but normally people will print in that separate line. So you end the if and the condition with a colon, then the command that we want. And you can also do an else if. All right, so let's try that. So x equal to 42. If x divided by 2, okay, basically the remainder of dividing by 2 is 0. then print even. Okay, so that's the printout. Okay, so you open even. And if I want to try everything in one line and I don't want to type new, I can maximize. I can maximize what I've typed before. Okay, I don't think I can get both. I can get this line and then I just add print. Okay, so yeah, so enter once and then it will say even lah. Okay. Okay, so if you have more than one thing you want to, if you have more than one item you want to print out, this is the where Python is different than other languages. You don't have to type in begin end. Okay, for example, if x is even, I want to have print x equals something. Okay, and I also want to print x is okay. I made an error here. Okay, both must be same type. Aha, indentation error. Okay, this is the if. Then I have to indent once. Okay, go here and indent once, and then I want to add this. The ordering is wrong now, but should be okay. Okay, so if x has a remainder of 0 when you divide it by 2, I will print two statements. So here, how Python does it is you need to indent once for every line that you want to execute, if that is true. Okay, so if the condition is true, it will print both lines, and you don't need a begin, end, or bracket or anything. So that's how easy it is to do multiple lines of code in based on one condition. Right, and then okay, let's try out the else if here. Not sure I can remember all this. Okay, so if x x is 42, so I don't have to do that again. Okay, so x is less than 10, and then once, okay, print x is a one-digit number. If it's not, then I want to check again, right? So I would check if it is false. I want to check whether it is less than 100. Okay, should be okay. Ouch. I have to put the variable here. Try again. Okay, I have to start all over again. Okay, there's a problem with this REPL. You have to make sure every line is correct. Otherwise, you have to start again. So I will start from here and look for the code that I have just now. This code. Then I have the else if. Okay, and then print x is a two-digit number. And then I can have an else. Yeah, I can say okay. X is has more than two digits. Okay, so because x is still 42 previously, so I should get x is a two-digit number. Okay, but right now, if I want to change x to 100 or 1000 or maybe 999, okay, and I want to test again all this. Okay, there's 6 lines in the code. Sadly, I have to do all over again because this is interpreter. Okay, so of course, if you have a long logic like this, it's not recommended to use the interpreter. Instead, you should write a .py program. But anyway, let's try this just once at least. Okay, so I'm using the up arrow key on my keyboard to recall previous entries. So the C one's the one that match. Okay, so now I'm expecting the second print to be chosen. Okay, so X has more than 2 digits. Okay, so that summarizes the if, and else statements. Of course, other than that, you can try out for yourself. Okay, so for looping, we can use the while keyword. So this one, yeah, I can do this very quickly. Okay, now equal to 1, and then while number less than 5, we can print out. Okay, wow, I didn't add anything. Okay, emergency, Control C, stop. It's not the number was not updated, so it goes into a while loop. It's not a while loop, it's a while loop, uncontrollable loop. So yeah, I can print, and then I need to update x equal, sorry, this one is num, right? So num equal, let's try the C style. Okay, well, C style works? Nope, it doesn't agree. Okay, how about num equal to 1, while num less than 5, print number, then okay, let's try this. Okay, so this one, yeah, you can do this also in C, a short form of number equal number plus 1, but you cannot do the full C style plus plus. Okay, so this method is still acceptable. Num plus equal 1 will increment num by 1. Okay, so we will print number up to 4 because the number 5 is not included. Okay, or if you know how many loops you want, you can use a for loop. So the for uses what's called the range. Okay, for I in range 1 to 6, or for any range, and then we can print out. So let's try that out. So now I don't have to assign the number num. So I just say for num range 1. Yeah, if I want to get the same output as last time, I need to put 5 here, because number 5 is not included. Okay, see that? Number 5 is not included. So 1, 2, 3, 4, and then when it reaches 5, it actually exit the loop. Or you can also do this. Okay, if you want to start from 0, you don't have to put number 1, because this range is quite powerful. Okay, what is range? Actually, range is a series of numbers. Range print. I just want to test. Nope. You cannot do that lah. So if I want to put, for example, I put just range without the 1 in front, and I put, I print the number. Okay. So I will get the number starting from 0. Okay, so the first number, if you have two digits in the range expression, the first digit will become the starting number, and the last digit will be the number that you're not supposed to reach. Basically, you'll never reach number 5. So of course, if you do 0, 5, you should get the same. Okay, let's try only 1 line. Okay, so the same thing. So if you put 0, you will get the same thing, because 0 is by default the starting number. But if you want to start from other numbers, then you put the beginning number, and then number 5 will become the ending number. So now I will print from 2 until 4. Okay, so this range can be compact, but just have to be careful that it does not print the last number. Okay, lastly, if you want to print but all in one, so you have to use a special syntax for print where you tell it how you want to end the line. So I can do this and equal space. Okay, so I will print 2, 2, 2, 3, 4 like that. Okay, now let's go crazy. Let's print 15 numbers all in one line. Okay, so 0 up to 14 will have 15 numbers, but including 0, there will be 15, but number 15 itself is not included. Okay, so that's it for looping, quite easy, nothing much. And then we go to functions. All right, so in Python, functions are defined using the def keyword. So we can do this also in interpreter. So just say def square root x, and then the contents is whatever you want inside, but you must have a keyword return. Okay, the return keyword must be there, so I want to return the square. So now that function is already defined, and you can call it from the without using print. So you can, for example, just key in square 5, and it will give 25 because the function is already stored inside the interpreter. If you exit, it will be lost. So if you have a long function, make sure to put it in the file so that you can recall later. Okay, interestingly, in Python, functions can be passed as arguments to other functions. So in this case, we have already defined SQR as a square function. So now, instead of using the SQR, you can use the variable f. Okay, so we know SQR5 is 25, but f equal to SQR can be you can assign just like that. Okay, so basically now f will be square root function. So now this function f is a new function which behaves just like the square, and if you give it 5, I will still get 25. And you can also do fancy stuff. So you can combine, in my example here, you can define define fxy, where you have combination of x and y inside there. So this becomes quite complex. Define x and y, and then I have the inputs are functions. Okay, the inputs are functions, and what do I do here? I have, yeah. Okay. The first one is the function. Okay, so this is the function f, and then the inputs are x and y. So now to call this, I will for example, I give fxy is going to call this function fxy. As a parameter, I give square, which is the function that I want to use, and then the variable I want to use is, for example, 2 and 3. So I should get 2 times 2 plus 3 times 3. So the value will be 4 plus 9, I should get 13, right? So yeah, I will get 13. So function function can be passed as a parameter to other functions. Okay, that is something fancy in Python that may be useful, may not be useful. All right, and then the scope variables. This is something that also we need to know when we want to write a big program. Of course, we always have local variables and global variables. So the local variables are the one that are inside your function or closest to you, and the globals are the one quite far away. So if we have two variables with the same name, an instruction in the program will always use the one that's closest. So in this case, I have I'm incrementing whatever value, right? So, and whatever value that I have, I print inside the print statement. So in this def, okay, I will increment X and then the new value is printed out. So let's try this. Def increment input is X, and then inside here I have variable Y and X. Okay, the Y is a new variable, X is something from outside, and I can print X, Y. Let's try the simple one first. So what will happen if I just say increment 0? I will get 0 and 1. Okay, happens this way because X is still the same X, and then Y is something new that was calculated based on the X that was transferred to this function. So when I print both numbers, I will get 0 and 1. Okay, so if I put the increment 5, I will get 5 and 6. But the thing is, the X and Y are still, I can have also X and Y outside. If, for example, I have X and Y equal to 3 and 4 outside. Okay, and then I run increment 3, okay, increment 3. So I will get, ouch, not a good example. Okay, because it's the same number. Okay, let's say I put increment 1 here. Okay, what happens is, in this function, X will get 1 because it's passed through this function call, and then Y will become 2. So when I print XY inside this function, I will have 1, 2. But if I print XY outside, I have 3, 4. Okay, because this XY is not the same as the XY inside this function. Something like that. So, okay, here in this example, if the variable is not available locally, it try to find global variable with that name. Okay, so in this example just now, the X and Y, they are available locally, so it will print the one closest to it. Okay, so and then when you are calling a function in C, for example, normally the parameters are position based. Okay, the value that you give to the function will be based on the function. It will be based on the position of the variables. So this will be the normal thing. Okay? Def difference of X and Y, and I just want to print it. Okay, and then let's maybe print, okay, just print X and Y. Print X minus Y. So if I call diff with 5 and 3, I should get diff. If I call diff with 5 and 3, I should get 2. Okay. So basically, X will get 5, Y will get 3, but you can change that. Okay, you can change that. Okay, so the default is the same. X will get the first variable, and Y will get the second variable. But if you want to, you can swap both variables if you put the variable names directly. Okay, so I can do this. Diff X equal to 3, Y equal to, no, they will be the same. Okay, right now X will get 5, Y will right now. Okay, if you just say diff 5 3, you will get this. X equal to 5, Y get 3. But what if I switch this? 3 here and 5 here. Okay, so when I do this, the variables that will be given to X will be 3 and Y will be 5. So the answer should be -2. So you can change the variables that are being passed if you manage you put the name of the variable in the parameter list. Okay, and you can also have default values. Okay, so here I can have default values so that I don't have to put everything. So I can change this original diff command, for example, with y equal to 1. And I just print as usual, and then I call diff with 5. So I will get 4. Okay, I don't have to pass both variables. I just have to pass one. But if I post numbers, then the new number will be used for the second variable. Okay, so Python provides some useful built-in functions like min, max, absolute, and also length. Okay, so length is quite useful to find the length of a string. In C, you have to write a function yourself to find the string of the length of a string. And then we have a function to force conversion of a string to an integer. Okay, let's try that. Okay, for example, a equal to 15. And if I do a times 2, I will get 15, 15. Okay, because it's considering a to become a to as a string, and if you multiply a string, it will have the string twice. But if you want to have the value of it, you have to make it integer. So you can have integer a times 2. So now the string will become an integer, then it is multiplied. So I will get 30. You can also go the other way from integer to string. And also you can convert numbers to binary. Okay, so for example, I can do this conversion, binary 3, I will get 0B11. So binary 3 is actually 11, right? And then what about 255? Is we all those who are working with computer will immediately know if you have 255, we will have 8 ones. How about binary of -1? No, it doesn't know how to do it. So just put the minus and then 1. So the minus is taken out, and then they will convert 1 to just 1. Okay. So if you are using computers in two's complement, of course -1 will become a different number. So not really the same effect as in C. Okay, so this is all the functions, all the built-in functions available in Python. So we have absolute, the easy ones, binary, and then we have what's the easy one? Float. Okay, so float will convert your number to a floating point number, and then I think input is for getting input from the keyboard. Okay, and then we have min, mentioned already, and we have power, and so on. All right. So not all. I haven't used most of it. The number of functions that I've used myself maybe around 10. So please don't ask please don't ask me about this. So just click here on the functions hyperlink and you get the answers here. Okay, then we go to the another type of function called methods. So a method is a function that belongs to an object. Remember that we are talking Python as a language that supports object-oriented programming. So in an object-oriented programming language, a function can belong to a class or the object. So that means the function is now attached to the object. And in object-oriented programming, a function is called a method. So just to differentiate between a function, a normal function, and a function that works with an object, we call it a method. So in string programming, string processing is quite usual for us to convert string to uppercase or lowercase or whatever. But in Python, because a string is considered an object, you cannot use the normal normal function style. Okay? For example, if I have string A equal to hello, okay, in C what you'll do is you say, okay, str upr, and then you put A in the middle. And this is a normal function where the string is a parameter. Okay, so it doesn't work that way. So in Python, when you have a string, you have to do something with the string. You find out what are the methods that are available for a string, and then you call the method. Okay, so it works like this. Okay, you have A, which is hello, and then you type upper. So I get a new string, which is all uppercase, but the way to perform it is different because it's object oriented. So the way you call a function with an object is to put the object name first, and then put a dot, and then put the function name afterwards. So this is basically like if you have not done any object-oriented programming, this is maybe your first introduction to the funny things that happens when you use objects. Okay. So again, you can also assign to other variables. Functions can be assigned to other variables. So here, x equal to hello. Now, this f can become a function. Okay, you can assign x dot upper to become a function, and you can just call it. Okay, so a equal to hello. I think I've done it. Let's make it same. So x equal to hello. Okay, and then f equal to x upper. Okay, I don't put here. I don't put the bracket because now I want to capture the function. So if I do this, I will get hello as the output. But what if I do this? If I put bracket at the end, f actually will get the string. Okay. So now f's bracket is an error, but f is the string. All right. When we have many functions, we can combine them into a module, which basically is a set of functions in a single Python file. Okay, this one you can write yourself. So if you have many functions that you want to put in one place, put them in a single file and save it, and you can reuse the whole file by using the import keyword. At the system level or at the Python level, Python already provided a lot of modules, and they are called packages. So packages and modules can sometimes get used interchangeably. The main thing, however, is that package is a function library, a function library that is provided by Python, not by you. If you do it yourself, you call it a module. So let's say I require to use, I want to use the math package, but I don't have it. So at the command line level, I will type in pip install math. Okay? But of course, you have to install the pip first. Okay? pip is a command in Linux that you have to install to manage packages. So install pip first, and then you can add functions or add this package, all these packages as you like. Mano, you asked me, please tell more about the differences between object and function. They are not the same. An object is an object. An object can have functions. Okay, an object is a self-contained unit of programming. Okay, inside an object, you can have functions and data. That function is part of the object. Okay, maybe you want to do a simple object. Okay, like this. Okay, to create an object, you have to. Okay, I'm right now. I'm going ahead to object-oriented programming because somebody asked. Okay, so I can create an object like this. For example, I have a class cat, and then inside this class, I can have a function. Okay, maybe make a sound. Okay, make a sound. Okay, this one I forgot. Do I put the bracket or not? I don't remember. I don't. I think I don't have to. Oh, okay. I must put a bracket because it's a function. Oops. Okay, this is a class, and then have to inside the class I have a function called sound. Bracket there. Okay, and then here, if you call this, I will say meow. Okay, because it's a cat. Okay, now we have a class containing a function. So to use this, I have to create a cat first. So for example, I use Garfield. Okay, Garfield is a cat. So I will create an object called Garfield from the class cat. So cat is a template for creating objects. So now to call this function sound, I have to do Garfield dot sound. Oops. I failed. I think I need to add something. Yeah, back to the beginning. I have to put self here. Okay, that happens when you are rusty. Okay, so create Garfield again, and then let's see what Garfield what is this sound Garfield makes. So this is what happens. Okay, so you have a class which is a self-contained object, a self-contained unit of programming, which can be very big. Okay, you can have many functions inside the class, and then you can also have data inside there. I can add data inside there if I want, but I don't have data. I just have on a single function inside the class cat. So if I want to use something inside this class, I have to create an object called Garfield, and then I will have to put Garfield.sound. So that's why when when we work with the string just now, we have the dot and then the upper, right? Because the first word or the first variable, first you must have the variable and then the function. Again, I made a mistake, not a function, because because it's inside a class, it's called a method. Okay? But it's basically the same thing, but terminology-wise, it's wrong. Okay, so if you have many things that you want to do that is already available inside the package, just install the package. But for import, for math, you don't have to import. Just say import math, you don't have to install anything. But many other packages you have to install first. Okay, for example, here let's try import math. Okay, no problem. It will accept that. But let's say I want to import NumPy. Okay, it's already installed in this web-based interpreter is already installed. Okay, so I just import. But if you have your own Linux or Raspberry Pi, if you try to import NumPy, it will not work. You have to install it first, make it available to your program, then you can use. But anyway, if most math are not available, you have to install it using install math, pip install math, and then you can import, and then you can have all the functions inside there. And you can check what are the functions available inside math. Okay, so I have already imported. So I can say directory math, dir math. So how do I use this? For example, I want to find the cosine of 0, right? So I can use just math cos 0. So I get 1. So that's how you use a cosine function in Python. Okay, you put the package name first, and then the function name, and then the parameter. But if you don't want to type in math every time, you can put an alias. So I can say import math sm. So now instead of math, I just put m dot cosine given. Or let's see what happens if I put, okay, of course sine and tangent, they all work. So if I put sine 0, of course I will get 0. Can we find the list of packages, objects, and function method available? And then, no, the methods or the packages, the list of packages must be, you have to use Google. Okay, so you can find a list of Python modules or packages. Okay, here you go to this Python module index, maybe hundreds of them. Okay, long list with an index. So you can install any of these. So don't install something that you don't really need, because it will use up your hard disk space. Okay, use only the one that you need. Okay, so go here. Okay, for example, pickle. I don't know what it does. Okay, convert Python object to stream and okay, whatever. Okay, I want to just test out whether it is available in this free compiler. Import. So, it's available. Okay, this compiler has installed that in its library, but I'm sure I don't have it in my system. And so when you install Python on your computer, it's almost blank, and you just add in what you need. All right, so after you install, then you can find out what the functions available. So pickle is there. So what are the functions available in pickle? We can check it out. Okay, so this is quite long, but this is not enough. Not enough. It just gives a list of names, but no indication how to use. So that's why you still need Google for that. All right. So I'm introducing some other functions or modules here. I can have time. Okay. For example, I want to know what's the time now. I can do import time. Let's try without giving the time keyword. What happened? Time, ASCII time. Okay, time in ASCII format. I will not like it because the name time is not defined. So you need to import time first. Import time, and then one arrow later can have the date today. Okay, the time today, but this looks like time somewhere not here. Still 7 a.m. in the morning. All right, and we also have a sys module for accessing operating system level function. I think this example is quite complex. I think you can try this. I don't think we have time for this. I can try this one later. So what it really does is actually when you type in something on the command line, for example here, Python, try py, hello world. Okay, all these words, there's actually four tokens or 4 words. Python is number 0, try is number 1, hello is number 2, world is number 3. So you can actually print that out. So you can print out Python, you can print out try, you can print out hello, print out world. So you can do that by this variable called the argv, okay, .argv. But this one has to be written in the program. So I must create a program try.py, and then inside this there's only 2 lines, and then inside this program I print out only number 1, which is try.py. But because this online thing doesn't have a program, hey, wait, I can. On the left side. Okay, let's try this. I can. Okay. But no. I cannot do that because I cannot. I don't have a way to do. I don't have a way to type in Python and so on. Okay, this command I cannot enter the command like this. Okay, skip this example. And then we have NumPy. Okay, this is a very important module that can replace MATLAB. So it's very complete, okay, widely used in the scientific community and replace MATLAB in a lot of places, okay, because it's free. Whereas if you use MATLAB and you want to use it legally, you have to pay quite a lot. So here I have something that you will dream, right? Salary 2,000 and then increment 1.1. And then there's 3 people here, you, your friend, and your best friend. So salary of 2,000, 4,000, and 8,000. And inside we have put the salary of you 3 guys in the array, and then increment is 1.1, and then you just type in salary times increment, and every of this salary is incremented. So this looks just like MATLAB. Okay, let's try this out. Okay, import numpy s np. Okay. Okay, so you must put your numbers in a special array. Okay, so you call it np. Remember that np is a short form for numpy. And you put the numbers in this format. Okay, round bracket and then square bracket. 2,000, 4,000, 8,000. This is basically a 1D array. Which direction we don't care, right? Because it's 1D. You can go vertical or horizontal, it's 1D. So now if I type, if I check out the value salary, I will get the array back. You can always do this in Python anytime. So this array is only a numpy. It's not available if you don't install numpy. Then I can multiply salary with 1.1, and that's the new value. Okay, so basically the number 1.1 is multiplied with all the items inside the array. Okay, just like MATLAB. Or if you all didn't go to work for many days, you get salary divided by half. So that was happened. Okay, so can also do that, just like MATLAB. All right, so this is the basic part, very basic use of NumPy. Here is one example where you can appreciate the power of NumPy. Okay, you can see this equation here, where I want to, in this example, the mean square error is used a lot in machine learning, where you have a prediction and you have the actual value. Okay, so the actual value is, we call it label, and then the prediction is the one that we are trying to converge. So in this example, the prediction, we have three numbers. The prediction is 1, 1, 1 because we are just starting. And then we have the labels 1, 2, 3. And then we want to find the mean square error. Basically, what we want to do is 1 minus 1 squared, 2 minus 1 squared, 3 minus 1 squared. Or it doesn't matter in either direction because it's squared, right? So what we do, we can create an array called predictions for the three predictions. We can create another array for the labels for the actual value that we want, and then we can do minus. We can subtract the difference. We can find the difference. So predictions minus labels. So it will subtract item by item. So 1 minus 1 becomes 0 here. 1 minus 2 becomes minus 1, and 1 minus 3 becomes minus 3. Minus 2. Minus 2. And then we can square. We can square all the items inside there. So 0 squared becomes 0, 1 squared becomes 1, and 2 squared, minus 2 squared becomes 2. So just by giving this command np.square and bracket predictions minus labels. Now to sum all the values inside there, okay, we want to add 1 plus 0 plus 1, 0 plus 1 plus 4. We just say np.sum. And then the mean square error is the average of the error, average of the square of the error. Okay, so we have error. The error value is 0 plus 1 plus 5. The average is 5. That is the average or the mean. But then we have to. That's the total. That's the sum of the errors. But the mean means the average divided by the number of items in the list. So we just divide that by 3. Okay, but to make it more flexible, and maybe for example, maybe you do not know what is the size of the array, you can just do 1 divided by length of the labels. So the label here, or actually either one, either labels or predictions, since they are the same. Since the label here contains 3 items, so 1 divided by length label will become 1 divided by 3. So basically what you're doing is 5 divided by 3, we get 1.6. So let's try that. Okay, we have import already. So okay, predictions equal np array 1 1, right? We predict the value to be 1 1, but the actual value is 1 2 3. np array 1 3. Okay, so for the first prediction is correct. So I can immediately do this actually to get the to calculate all this. To calculate all this, I don't have to do all that. Just assign the values for the operation and labels, and I just say okay, np sum, and then np square square. Okay, and then predictions minus labels divided by 3. Okay, I can do that immediately. But in this notes, I do all the steps. I do the immediate steps, which happens. Okay, so now I have the mean square error. So if I want to make it like more flexible, I can have can have it divided by the length of labels. It's still the same. And now I can change this. For example, I want to make it a bigger array. I'm going to make it a bigger array, maybe 6 items. Okay, prediction is 6 items, 6 elements, and the labels also 6 elements. Here I make it okay 4 5 6 lah. Okay, then the array size change, but now the equation is still the same because I put the length labels at the back. So now the whole number will be divided by 6. So I will get something bigger, of course. All right, so this is NumPy. Okay, so if you have a NumPy and you figure out how, then you don't need MATLAB anymore. So this is what a lot of scientists are doing today. They can use free operating system, Linux. They don't have to buy Windows, and they use free Python with free NumPy, and you can do your experiments at a low cost compared to buying MATLAB and Microsoft Windows. Okay, so these are some of the popular Python packages. Number one, NumPy, numeric Python. And then we have scientific Python, SciPy. It makes use of NumPy. You have to install NumPy first. Or if you just install SciPy, it will install NumPy, because if you use pip to install SciPy, it knows the dependencies and it will look for NumPy and install both. So the SciPy package does high level things like clustering, integration, whatever. And then we have pandas to analyze tabular data like Excel. So if you have like database of student marks that lecturers like to get the average or find whatever you have to do, like find the standard deviation or whatever, or table-like data, you can use pandas. And pandas will know how to use CSV files. Okay? So if you have data from Excel and you want pandas to process it, just export the data in Excel as .csv and pandas can read the data. And then we have matplotlib. Okay, looks like a mathematical plotting library to create charts and plots. So if you are tired of Google Sheets or your Microsoft Excels and you like some challenge, then you can use pandas and matplotlib plus Seaborn to create your graphics. And then we have scikit-learn for data analysis and machine learning. So this is quite important also for data analysis because a lot of people are relying on this one today for what's called data science. Okay, you have a lot of data that you want to process, not just what Excel can do, but also maybe find the patterns inside there. So Excel cannot do that, Google Sheets cannot do that. You want to see the patterns inside there, you want to do regression, whatever, you can use scikit-learn. And then we have the request and URlib for HTTP programming, basically talking to servers, so that you can create IoT and send data to a server. And we have NLTK, Natural Language Toolkit. I tried this one, I gave up. Okay, it's for computational linguistics. For example, you want to analyze the student comments. Okay, a lecturer has 1,000 students and he wants to know whether he is popular or not. He can use NLTK to process all the comments inside the EPPP and find out the sentiment of the student, whether it's positive or negative. Okay, they hate the lecturer or they love the lecturer. You don't have to process one by one. You process using NLTK, which of course knows English only, and it will do that quite accurately. Okay, because this package has been developed for quite some time. So you can do what's called the sentiment analysis or opinion mining. If you want to do in Malay, you cannot use this, but there's a package called Malaya. Okay, so Malaya package was designed, I think it's still active. It's all specialized for Malay language. Same function, but for Malay. And then we have Pillow for processing images. So if you want to create thumbnails or do some filtering, you can use Pillow. And then you can have OpenCV to do computer vision. If you have a robot, you want to, you have a robot and want to use Python to program the robot for the vision part, you can use OpenCV. And then we have PyTest for test automation. This is of interest for people who have taken subject software engineering. When we have a big software, big package, to test everything one by one takes a long time. So we have what's called the test automation. You just run one program to do all the testing for the program. And you need this package called PyTest to isolate where is the bug in the program. And then we have TensorFlow. This is my favorite. Actually, TensorFlow comes with something called Keras, Keras. They come together nowadays. So this is for AI and deep learning, and there's also PyTorch. PyTorch and TensorFlow about the same, but they come from different people. And some pluses and minuses for each. But PyTorch is used a lot by people in academia. TensorFlow is a lot by the industry. And then we have Django for creating websites. So all my students must use Django. Okay? All my students this semester must use Django to create the assignment for software engineering. And lastly, we have Pygame. Okay, so this is for game development. Okay, so Pygame is so simple that my son now is doing PhD lah. But when my son was still in Form 4, he used Pygame to create his own game. So he learned Python by himself at the age while he was Form 4. So Python is that easy lah. So you can create a game without taking a formal subject. All right. I think we take another short break because the last section is not going to be that long. So maybe I can entertain a lot of questions from you. Okay. So another short break.
PM name. I cannot read the question. Maybe they send private to you, right?
No, I don't have. I don't have. I have only one question.
Ah, I see. Okay.
Oh, yeah,
So
yeah. This
if,
Mano guy sent to me privately, but only one person.
I see. Okay.
He
So
asked.
if you have any question, you can drop in the chat box to Prof. Munim. And also please, okay, I will ask here Mano. All right, Mano. And also please fill up the attendance if you have not done it yet.
Okay, maybe I will assign. Dr. Izala, how can I make you a co-host?
Right click at my name and you can assign as co-host.
I don't see the option. I don't see the options. Let me see more options.
Oh no?
More options.
Right click at my name also no option for co-host
Not,
assign?
not yet.
Oh, not yet.
Not yet.
Okay.
Because maybe we'll do an informal survey here, or maybe you want to create a Google form for feedback.
I already create the Google form and feedback so they can fill up the attendance. It is actually together with the feedback.
Okay. Oh, okay. Okay, together with feedback. Okay.
And they will get their e-certificate as well.
All right. Okay.
All right. I have already filled the attendance. All right. Thank you, Mano. No, one time only.
No, I cannot transfer the co-host. I cannot do anything.
Wonder why. It's okay. I will still be here
Okay.
until the end. No worries.
Who is the farthest from here? Who
Oh,
is
fathers. Is it Mano? Fathers from UTM, you mean?
farthest from UTM? Anybody outside the country?
All right. Okay. Anybody outside from Malaysia?
Yeah, I'm from Pakistan.
Pakistan.
Okay.
Too. I'm from Libya.
So you're accessing from Libya now?
Yes.
Oh yeah. What's the condition there?
Sorry.
Nigeria also. Oh, Nigeria is doing well, right? I heard Nigeria is making the first airplane. I watched on YouTube. Malaysia is still a long way behind. Okay, guys, let's continue. I think this is the last section. Okay, so this part is one of the harder parts. Okay, harder, or maybe I should call it interesting parts of Python. Okay, so it's called collections. So this is an advanced data type. Something that if you want to do this in C, it's not that easy. But if you know how to do this in Python, makes your life a lot easier for whatever you want to do. All right, so for the first is the definition. Collections are containers. Okay, collection of containers are objects that holds an arbitrary number of other objects. Okay, or we can say also collections are containers that contains other objects. So there is a once you after you use after you in using containers or in using collections, there is a way, a standardized way to access the contained objects. Okay, you have a container inside there. There's some objects, and there is a standard way to go through each item in the object, in each object in the container. So there is a standard way to access objects inside the container. Depending on the collection type, the methods are different, slightly different, depending on the object. Okay, so first one is called a list, and then we have tuple, we have set, and dictionary. Okay, in computer science, the term mutable means changeable. So when a list is mutable, that means you can change the value inside the container. For example, inside this container, I have two numbers, 1 and 2, okay, 1 and 2. So I can change 1 and 2 to become 3 and 4, or whatever value that we want. That is a mutable data store. Okay? The data inside there can be changed in value. So here we have two that is mutable and one is immutable. I have to check back why I didn't put set for either mutable or immutable. Anyway, list is mutable, ordered and indexed. Okay, what that means is that ordered means the item inside the list will have a certain sorting order. Okay, the order is always the same. If you put number one before number one first, and then you put number two inside there later, so the sequencing will always be the same. Okay, number one first and then number two second. If it's unordered, that means you put the number there. It's just like it's your when you put you put some values there, and when you take a number out, it can be random. You do not know which number you will get. For some applications, that is okay. So that's why all these data types are provided. And then lastly, we have what's called the index. Index means the item inside the, excuse me, I have to check this phone call. Sorry, my daughter is calling from school. I'm supposed to pick her up, but way to be late today. Anyway, so okay, so index means an object there has a number. Okay, so item 0 or item number 1 or item number 2. Okay, unindexed means the objects that are jumbled together and you cannot access the object based on a number or an index. And then there's also the last one is allow duplicate members. That means you can have two items with the same value inside the list or inside the tuple, but not for set and dictionary. Okay, so we will go starting from the easiest, which is the list. Okay, we have seen the list actually when we used a NumPy just now. All right, a list is a collection that is ordered and changeable, and you can identify that with the square bracket. Okay, whenever you put a number in, put a list in square bracket, that is a list. And you can implement arrays found in lower level languages like C. Okay, so if you have a program in C that you want to convert to Python, C can only do array, they cannot do the other advanced data types. So you immediately will go to the list. So inside the list, you can put data of any type, okay, and you can even mix the data types. So you can have X equal to 1, 2, 3, or X equal to durian, mango, banana, or whatever, or you can mix. Okay, let's try that. Let's try that with our web compiler. Okay, let's do this. Okay, X equals 1, 2, 3. Okay, and then just type X, and we'll get back X. All right. I just have this crazy idea. What if I sum X? What will happen? Hey, I can, there's a built-in function called sum. We will get the total of all the numbers there. Okay, and then I can also have X. I don't want to put fruits. I can put X there, but here I can put the Malaysian fruits, banana, mango, not really Malaysian, but also available outside, and then durian. Okay. Typo there, but anybody spot the typo? Okay, now can I sum this? Cannot, right? Because they are not integer. Okay, how about if I force them to be integer? Just experimenting. Still cannot, of course. Bananas can never be converted to integer. All right, so that is the intro. Okay, and then you can also mix things. Okay, for example, I can have X equal to 1 and then banana. And then maybe a floating point number here, 1.25. Okay, let's try to sum that. Of course cannot, because there's one inside there that is not a number. Okay, and then you can also have a list inside the list. Okay, so here in this example, we have a list. First, the list can have mixed data type, can have integer, floating point, and string, but also inside the list, you can have a list. So I can have 1. Okay. Inside here, I can have banana again, and then 2. Okay, so this is a list. Inside this list, and then I have apple. Okay, so number 2, the second item is a list which is inside the bigger list. Okay, no problem, we can do that. So lastly, we can have the length calculated automatically. So for example, here I just say X, length X. What is the length, or what is the number of items inside there? I have 3. Okay, so this list is considered as 1 because looking at the higher level, it looks like it's only 1 item. But inside there, if you go inside, then only you can see there's 2 items there. So at the higher level, the length function reports 3. Okay, so you can access the individual items in the element. The first item is index 0 and so on. Okay, so okay, this example is quite lengthy to type. Yeah, I just put numbers now. Okay. So X equal to I will do countdown, or maybe I will do double numbers like this. Double digits. Okay. right? And then I can find out what is the first item or item number 0. So X bracket 0 will give me the first item. Okay, counting like a human is normal, first item, but it is number 0. Okay, and then I can go up to X4. And then if I do X5, it will report list index out of range because the index only goes to 4. Okay, so there's only X0 up to X4. And then you, because you have a list, you can access the list or sub list. You can access part of the list. Okay, so let's say I have X, but I want only up to number 3. From number 3 downwards. Also, I can do this. 3 colon. I will have item number 3 and number 4. Okay. So this is a way to chop a list. Okay. Instead of you don't want, maybe you don't, for that particular example, for that particular calculation, you only want a slice of the big list. So in this case, I will take item number 3 onwards. So I will have number 44 and 45 only. Or I can take a number from number 0 up to number 3. So I will have 1, 1, 2, 2, 3, 3. Okay, remember that the number on the right will never be reached. So I will have X0, X1, X2, but not X3, even though in the expression that I put X colon 3. And you can also do like this, okay? 1, 2, 3 only. So I will get 1 and 2. So I will have X1, which is 22, or the X2, which is 33, but I will not get X3. So the chopping of a list can get very interesting. And you can also go from the back. Okay, what is the last item? I can go X minus 1. That is the last item. That is number 55. And the second last item, my X minus 2. Okay, and so on. All right, and then we can use a new, not new, we have seen the 4 just now, but now knowing that this is a list, we can actually iterate or go through items in the list using the 4 keyword. So look closely in the examples here. So I think in this case I will I need to type in everything. Let's try to copy paste. It works. Right. Yeah, let's try fruits here. Oops. Paste. Okay, it works. Right. So if I type in fruits, of course I will get everything. Okay, but in the program you cannot do this. You have to print. So when you're printing one item by item, you have to do for loop. But this for loop will go through all the items in the list. So for fruit, in fruits, okay, this is singular. That means one fruit inside the fruits list. In fruits. Yeah. Then it will basically in one round through the loop, it will take durian as the fruit. Second round, it will take mango, and the third round, it will take banana. So I will just say fruit. And I will print all the items one by one. Okay. So there's no index involved. If you want to do this in C, you need to have index number 0, index number 1, index number 2. Here, no, it will just go through all the items in the list, and we don't care what is the index number, right? And yeah, remember that we have the term identical items, right? Can the list contain identical items? Let's say I have mango twice. Will it work? It works. Okay. So in a list, you can have same item twice. So if I go through, even if I go through this loop, I can still print. I can still print 2 mangoes. So you can see later there is data type that doesn't allow that. Right? So if you have a list now, and you want to add later, okay? you have already, like just now what I did was I want to add mango, but I create a new list actually. Now I just want to add one item and I don't want to give a new statement or a new command. I can just say append. So this append can only append one item. Okay, so let's try that. Okay, fruits. This is remember that this is an object, and when you have an object, you have a method. Okay, the method is called append, and I want to add kiwi fruit, and the new fruits will be a new object with which is longer. It's longer. How about if I try to add two items? Okay, it's not allowed. Okay, so for append, you must append one item at a time. And you can sort. Okay, so yeah, you can sort. So you can sort that alphabetically. So this sort method will work on this object and sort. Sort, you cannot see that result yet. So you print out the new fruits. So we have, banana, durian, kiwi, mango, mango. Lastly, we want to remove an item. So when we remove an item, it's always you have to put the what you want to remove. So fruit, remove mango. Let's try this. Will it crash? Because I have two mangoes here. It's still quiet, right? Not saying anything. How many mangoes left? I still have one mango because it can only remove one mango at a time. What if I just remove without saying anything? Cannot. You have to specify what is the item that you want to remove. Okay, second type of container is called a tuple. A tuple is written with round brackets, and the main difference is that the items inside here cannot be changed or unmutable. So okay, the easy way to do this is just copy this one. I don't want to do so many typing. Okay, go back here and then put round bracket. Now I have a tuple. And let's do that. Roots. Okay. So now let's sort. Root. Sort. Does it work? Cannot. Okay. Because for one, it's unmutable. Immutable means you cannot change it. So because of that, this time the fruits cannot apply. You cannot apply the sort function or the sort method to the fruits object. Okay, so now the fruits is a tuple. It's no longer a list. So now you cannot apply the sort method anymore. Right? But still you can access it using the square bracket. So for example, I can say fruits 1. I should get mango, yeah, because this ordering is durian, mango, banana, mango. And you can also specify the range of index just like right now. Okay, so I can say okay, 2 to 3 for 2 to 4 for example. You can have that subset of the whole tuple. And then yeah, you can even write tuples without the round brackets. Okay, I forgot about that one. And how do you add things? So the thing is, once you create a tuple, you cannot change its values. So if you want to change the value inside there, you have to convert that to a list and then back to tuple. Okay, so can we remove one point? Can we append? Just to test, right? We are curious. Since it's immutable, so append kiwi. Nope, cannot. How about remove? Remove mango. Okay, doesn't work. Okay, so because it's immutable or unchangeable, there's a limited way that you can work with a list. But a list can be very useful because at times you want a list of items that you cannot change. for safety, so that you cannot change it accidentally. So convert that to a tuple. So if you want to still modify a value inside the tuple, convert that to a list first, and then convert back to tuple. Okay, so for example here, fruits, I have mango twice, right? I want to change one of the mangoes to become kiwi. So what do? I make a new variable. Okay, so but I put list here, so I convert that to a list. So now I have list fruits. So now I have wine, which is a list, and I can either remove and add the mango, or I can just change it. Okay, for example, I want to change the last item. The last item is accessible by the index -1. So I just want to change the last item from mango to kiwi. I can do that. And if I check out the value y, I have it, I replace it already to kiwi. Now I convert y back to a tuple. So fruits equal tuple y. Okay, now I have a new tuple with the change value. So you have to do that. It's a long way, but it's also for security. Okay, for many applications, we don't want to accidentally change things, and it's for safety. So this is how you to do it if you really want to change something inside the tuple. And then you can also determine if a specified item is present in a tuple. Okay, so you want to check whether banana is in the tuple. So you can just do this. You can just use this condition. Check it directly. Okay, banana in fruits. It will say true. Okay. So what Python will do is compare all the items in compare banana with all the items and report whether banana is inside the tuple. Here is quite long. You don't have to do that. Okay? You don't have to say if banana in fruit, pre, no, you don't have to do that. Just say banana in fruit. True. Okay, done. Okay, item number 3 is set. Okay, yeah, we have 48 now, so I think there's enough time to finish. So we have a set. Okay, a set is a collection that is unordered and unindexed, and you write it with a curly bracket. So now, again, do it the effective way. Instead of typing everything, maybe just recycle whatever list that we have up here. Okay, this one. Just convert that to curly brace. See if it accepts mango twice. Yeah, okay. Mango twice is acceptable. And if check the value fruits, it will say, it will report back the number there. But it doesn't say set like that. Yeah, I have to update my notes. This is from an older version of Python. Not that old. This one, it wasn't done 10 years ago. So Python is changing. So yeah, this one better. Okay, because the curly brace is there, so you know that it is a set. Okay, so the order of elements could be different than originally entered. Let's see. Yeah. So the mango, remember, see that mango, only one mango is there. And then the ordering is also different. Mango comes first. So now it doesn't allow more than one item. And more, it cannot allow identical items, and then the ordering is different. And let's check whether it will allow us to access by index. So cannot use index. You cannot use indexing with a set. But you can still use the for loop. Okay, so the indexing doesn't work because the set is unordered. Okay, the ordering can be changed, and you do not know how. And then you cannot change the item inside there, but you can add items. Okay, so you can add here. Okay, how to do add? Okay, I want to add kiwi. Okay, fruits, add kiwi. And new list is now, the new set is now like that. Kiwi is in the middle, okay? So it doesn't even put it at the back. And you can update, okay? To add more than one item. Okay, so let's do this. Fruits, update to add more than one item. Okay, I put grape here and apple. Fruits, the new fruits is now what happened. Okay, I'm lost. I don't know what happened. Looks like it, when you do update, it will chop everything to characters, individual characters, and store the individual characters. Wow, okay. Don't use this. Maybe it's because I put single quotation. Okay, let's try update with on double quotation. Try this one. Nope, still the same. Okay, so avoid update. I'm not sure what happens. Okay, anyway, you can remove an item using remove or discard. So you just say, okay, I want to discard roots. I want to discard the character E. And check. Okay, so now one is gone. Okay, so you can do that, or you can just say pop. Okay, when you say pop, it will remove an item, but we do not know which one it will take. Okay, it's like you have a bundle of fruits there, and I want to take anything from there. So I will say fruits, pop, and that is the new item. Okay, that I'm taking kiwi out from the list, out from the set, and the new set will no longer have kiwi inside there. Let's pop again. I will have durian. Pop again, I will have R. And also, of course, I think I can save it somewhere. Okay, let's try that. Save roots. Pop. And save. Okay. So you can save the value that is being popped to a variable, and you can use the variable collected. Okay, so the actions that you can use for the set is different than the others, because of course it's a different kind. And lastly, the most powerful is called the dictionary. Okay, dictionary is like a database. It's like a mini database in the memory. Okay, database normally is in hard disk. It's bigger, but here we have database which is in RAM, which you can access very quickly. So to access this, you need to know the idea of key and value. For every entry inside the dictionary, it must be in a key value pair. It must come in a pair. So here in our example, I have a bike. The first key pair is called brand Suzuki. So key is the brand, Suzuki is the value. And the second pair is the second key value pair is model and Hayabusa, and the third key value pair is year end 1999. Okay, anybody know what is the good what makes the Suzuki Hayabusa famous? Anybody can enter in the chat. Anybody want to say something? Why did I choose this particular motorcycle? This is a super bike. Anybody know? Okay, while you're thinking, while you're googling. Okay, let's key in over here. Right. Bike. Cool. Okay, so you have to put curly brace first. Make sure the name is same. Okay, brand. Okay. Brand. This is the key, and then this. Yes, Jahan Zep is the fastest bike ever. No bike is faster than Suzuki Hayabusa because after they introduced that, they limit all the motorcycle to 300 km per hour. So it's the only motorcycle that can reach above 300 km per hour. If you still have this in Malaysia, I think many people will die because in Malaysia people don't care. And they just ride way above the speed limit. Okay, so we have 3 key value pairs, and let's report on the items. Yeah, like that. Yeah, horizontal, but the item is the same. Now we can access the dictionary using by giving the key, and it will report us the value. Okay, remember that key value, key value, key value. Now to access an item, we give the key. So bike brand. Okay, with the key brand, I will get Suzuki bike. Same with the other 3, of course, but let's just do one more. Okay, so the year is 1999. So it always works like that. And it doesn't allow similar values. Okay, you can change the value if you want. Okay, for example, here I want to change it to 2000. I just change it just like that. Okay, so this one is okay. It's mutable. You can change it. Right, and then what else? You can add the item. Okay, right now we have 3 key value pairs. I can add one more. For example, I want to add the color. So I can say bike color equal red. Okay, now get the report. Yeah, we have the new one. The color equal red is added as the last key value pair. So we can delete a key value pair or delete an item. Okay, we can delete one item. For example, I want to remove the year. Okay, I just say, okay, what do? Delete. Okay, delete. Okay, this one I cannot remember. I have to go back and check. So delete bike year, for example. Now the new dictionary will not have the year anymore, right? And then we can have pop, so that you can pop whatever value that you have, and then whenever you pop, we will no longer have the item or the key value pair inside the dictionary. So the pop method let you specify which key, but the pop item just remove the last inserted item. And then depending on the version, the item removed is different. So you have to know which version. In version before 3.7, a random item is removed, but in version 3.7 and newer, it will remove the last item. So let's save this temporary. Okay, bike pop item, bike pop item. Okay, so we pop the last one. So hopefully it's straight. Yeah, and the bike is shorter, and the pop item is stamped with the key value, color, and red. And as in the list and also the rest, we can iterate through the loop. So here we can just say for animal in mammal, split animal. So same thing here. So I can do for, but there's only 2 items there, but anyway, for I, getting lazy. For I in the name, fruit, I think this is bike. But to print, you have to put the variable I. So it will just print the keys. It will print the keys only. So when you do this, it will print out the keys only. Hey, this is wrong. This is not. Anyway, Yeah. Wait a minute. This is going through a list, tuple, or set. Okay. I forgot to check the header. All right. Okay. So in a list, tuple, or set, the method to go through the dictionary is the same. Okay. Because there's no key value. There's no keys, only values. So it will go to all the values. But if you are going through a dictionary and you do that, it will only give you the keys. So that's what happened here. Okay. So we have brand and model. So those are the keys. But if you want to only print out the values, you have to do a little bit more. So here I will need to put by X. Okay, let's do that. Print by I. Okay. Okay. Now I will get both. What do I do? What will happen if I do this? Print I. I can also do that. Okay. I can print key value pairs like that. So going through the list, going through the dictionary, I print I and byte I. I don't have to be this complicated. Okay, so this last example is making it too complicated because I am trying to show how you can do fancy print in Python. But if you just want to check out the value, no need to put the %s. Just print like that. And just print I and byte I. So if you print I, it will only print the key but not the value. Okay, and then we have, let me check. Okay, yeah, only one was light. Only one was light. So we have special methods for dictionaries. So you can list out the keys, you can list out the values, you can list out the items. So for dictionaries, there are some special methods available. So let me just say byte is, can do that, and then values and items. Okay, if you look closely inside the item, there's two tuples. Okay, if we define anything with a round bracket as a tuple, then you have two tuples inside there. Okay, so I think that's it. I think as a conclusion, oh Mano, you're asking. Yeah.
Manu got question there?
Yeah. I was just looking at it.
All right, okay.
Yeah, will you please tell what is the rule of empty at the end of some commands? Empty bracket. Oh, okay. Because you have an empty bracket because you have a method. So whenever you have a method, you must put empty bracket. When the method is not expecting anything. Okay, for example, just now we have a string, right? String. Okay, we have a string test. Okay, and then we want to change it to upper. I think this is what you mean, right? Yeah. In method, I think it depends on the method. Okay, you have to look at the method itself. For example, here byte.keys or byte.values. Okay, anytime you have a dot here, that means these are objects. And then for string, this is also a very simple object. The byte and all this is more complex objects. So if you are still stuck in the C world, okay, if you're stuck in the C world, you will see the function will look like this. Okay? Instead of string.upper, you will do this. You will do upper and the string. Okay, of course, it doesn't work. It will not work. But if you are doing it in C, it will be like this. And maybe for the byte example, you say keys, byte, something like that. Okay, but because it's object oriented, the method comes later, and that is how it's done. Okay, so that means it's a function. It is a function, or in object-oriented terms, it's called a method, and it doesn't need any other parameter, so you must put the blank whatever parentheses at the back. So it all depends on which method you are referring to. So you have to go to the reference and maybe see some examples. So that's how I will do it. There's no easy answer. There's no one answer fits all. It's a case by case. Okay, so yeah, I think to recap. Okay, so here are some of the famous packages. Okay, I'm getting slow. These are the packages or the modules that are famous. Okay, so for web framework, for web development of frameworks, we have Django. For game, we have Pygame. Big data, I can see an elephant there, but I don't know what does it stand for. And for web testing, we have SE. Actually, this stands for Selenium. There's a package called Selenium for web testing. Okay, just now I mentioned something called PyTest. That is for general purpose testing. But if you are doing a web server and you want to make sure the web server doesn't crash, or maybe the user doesn't get an error input, you have to test a lot of things you have to test. So to do it automatically, you will use the Selenium package, which will send data to the web server and do testing for you. So SE is a it's a rare material, right? It's a rare element, so they just put SE there. For the AI data science, I know TF there. Okay, see that the orange thing there. TF is TensorFlow, but I'm not sure what is the other one. Also for IoT, not so sure. Yeah, three of these icons I've never seen before, because I'm not in that area, so I do not know. So anyway, yeah, these are the main things that you can do with Python. So if you are still interested in hardware, I recommend get a Raspberry Pi and start playing around with it. So many things you can do if you have time lah. Okay. Other than that, you can also do game development, but not sure if it is the correct thing to do, because if you are doing really expensive game that you want to sell, you cannot compete with Electronic Arts or big companies like that. And they will probably not use a Pygame. They will probably use their own game software. But if you are doing like something simple like Wordle, anybody try Wordle? I tried Wordle for 2 days already. Anybody know what is Wordle? It's designed by Christopher Wardle. So it's getting famous nowadays on the web. So yeah, slow games like that you can use Pygame. Django, yes, you can do outsourcing. Okay, so from your home, if you know how to do websites, you can do your job from home. Actually, my brother, he is working for a US company. He works from home, so at night he doesn't sleep because he has to maintain a server in the US. During the day, he sleeps a bit and then takes care of his matters. So you have to know if you are good in Linux and you know Django, you're all set. But you do have to add a little bit more, not just Python. Python is knowing from whatever you have today is just a bit to get you started, and then you have to choose where you want to go further. Maybe you can find a list of job descriptions that require Python. From there you can move on. Okay, so you cannot be too choosy. If somebody from the US is saying, okay, you have to stay up all night to maintain the web server, that's what you have to do to earn your salary. So not to be choosy, but whatever you have to do is just a starter. Okay, so if you have any question, you can contact me directly. And there's not too many of you, no problem. not too many of you, it's not like 100 people attending today. So you can contact me directly using WhatsApp. Yeah, no problem. All right, I'll be glad to help you out. Okay, Dr. Izala, back to you.
All right. Okay. Thank you very much to our speaker, to our self-esteemed speaker, Associate Prof. Munim Zabidi, for your very fruitful sharing on Python. So it is eye-opener for myself, okay, and I think for all participants too. So on behalf of the task force, I would like to express our gratitude and appreciation to all participants for participating in this event. So I would like to request to take photo with all the participants and with the speaker. I think I can see some lecturers here. Can you on turn the camera and we shall take picture together? PM Munin, can you unshare the slide?
Okay.
All right. Okay. I think all participants, if you can turn on your camera. Dr. Nurzana, I can see Dr. Nasrul. All right, I can see Manuj. How are you, Manuj, over there? All right, okay.
Hear me?
Yeah, I can hear you. How are you there?
Fine, thank you so much. So nice to meet you and Prof. Munim again. And thank you for this useful session.
Yeah, all right. Thank you. Nice to meeting all of you. All right, I shall take the picture now. Okay. 1, 2, 3. Okay, done. All right. All right. Okay, done. Okay. Thank you very much, all. Thank you for joining.
Thank you.
And Assalamualaikum.
Salam.
Oh, I can see Abu Bakar just turned on the camera. Maybe we can take another one. All right. One more. Okay. Sorry, Dr. Azira. All right. Okay. All right. Everybody on? Okay. 1, 2, 3. All right. Thank you very much.
Thank you.
Okay.
For
All.
staying
Thank
until
you
the
very
end.
much.
Thank you
Okay.
so much, Prof. Thank
Yeah.
you.
Yeah,
Thank you.
thank
Welcome.
you. Associate
Welcome.
Prof. Name. Thank you.
Thank you.
Yeah, you're welcome.